Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Data Science and Business Intelligence meeting. We have with us the one and only Rick Pack, one of the few members of the board, the proud, the TriPass board. Before I do hand it over to Rick, we are going to briefly talk about SQL Saturday Richmond. So, SQL Saturday Richmond is coming up on May the 18th, and I dropped a link to that in chat. Registration is coming up soon. You'll be able to register for the event. It is free. There's a minor cost for lunch, but the call for speakers is actually still open until March 31st. So you'll have the rest of this week if you are interested in speaking in Richmond. If you're in the Triangle area, that's about a 2.5 hour drive, depending on where you're at. So give it a go. SQL Saturday Richmond is always a great event, and I highly encourage people to get out there, especially knowing that we're not going to do one in Raleigh this year. We may do one next year, we'll see. But if you want to have an event that's fairly local, that one's coming up in May. There's also a SQL Saturday in Atlanta on April 20th, and you can check that one out as well. That's a much bigger event out in Alpharetta, but that's also a great event. So check both of those out, SQLSaturday.com. Now, with the promotion aside, I'm going to hand it off to Rick Pack, who's going to talk to us about Kaggle data outliers using R and Python. So take it away,
Thank you
Rick.
so much, Kevin. Thank you, Kevin, and I hope you do get the opportunity to speak at SQL Saturday Richmond. I'm happy that all of you have joined me today for what I think will be a fun presentation and one that will allow you to learn from some lessons I've learned as I often attempt to do with these presentations. As Kevin said, we are going to be talking about Kaggle data outliers using R and Python. So we'll be discussing the reticulate package for interoperability between R and Python, as well as Kaggle data science competitions, which are free, kaggle.com with two G's. Oh, I forgot to put all of the notes here. But so among the goals for today include using the reticulate package for R, which allows for R and Python interoperability. So we'll engage that, as well as Kaggle competitions, and talk about how outlier detection can facilitate engaging these competitions given how complex they can be, and understanding that we all have limited time for sort of past time investigations. A little bit about me. I've worked professionally in broadly defined data science for 15 years as of this year. I have a master's degree in applied statistics from Penn State University. I serve as a youth mentor for an organization called 100 Black Men, which has existed for quite a while. Jackie Robinson, I think the first major league black baseball player, was one of the founding members. And so we work with youth just to give them a positive sense of what they can do with their lives. The organization's motto is "What they see is what they'll be." And I also run in Masters track meets, focusing on the 400 meters. Most relevant for this presentation, I have participated quite often in Kaggle. I've been involved with Kaggle competitions for 8 years, and you can see some of these medals on the bottom right. I'll talk about those a little bit. When you work in Kaggle competitions, if you have not, you can you can provide up and down arrow feedback, support or not so supportive feedback to individuals. And so I have earned enough of these up arrows for work that I have contributed to be considered I think it's expert. I just blanked expert status Kaggle participant, which is um, I'm quite proud of that. I'm a little surprised, and sometimes I get surprised by the support that I get for work I've done. So in the middle here, what I'm showing you is a notebook that I created. In Kaggle, you can create notebooks in Python and sometimes R
Oh, Rick,
and
you're still
execute
sharing
code.
the PowerPoint.
Huh?
You're sharing the PowerPoint, the first slide on the deck.
Oh, it's not progressing.
Nope.
Oh, why is it not progressing? That's different. Uh, is it progress? Do you see a different slide now?
No, you might be sharing a different screen. I'm so I do see actually
I'm
the
sharing the wrong.
yeah, I see the editor window.
Okay, okay, okay. 1 second, please. From current slide, is that better?
Negative. You may
No.
have to stop sharing and then reshare. Reshare the window that has the slide deck, the screen that has the slide. If you've got two monitors,
I have one, but you gave me an idea. So 1 second, please, everyone. I made the sharing full screen, and then I'll switch my screen to that one, maybe. Here we go. Thank you. I have to actually share the slideshow.
there you go.
Okay. So you were able to see the content. The content was just in a smaller window.
We were stuck on the first slide, so this is the first
Okay.
time we've
So
actually seen the About You slide.
okay. Oh well. So okay. So I think I highlighted the most important bits here. So we'll start here then. So as I said, the up arrows and down arrows contribute to feedback that we get. Feedback scores that we get for Kaggle competitions. You can be scored based on data sets you provide to others, notebooks that you create with code, your comments and discussions, including both your posts and your replies, and how you actually perform in the competition. What I've highlighted on this screen is that in a competition by Optiver, I'm not sure who that is exactly, but they had a competition to predict stock closing movements in the United States. And I was surprised that this notebook was received so well. What you can do in Kaggle, and really would love for you to try if you have not, you can copy another individual's notebook by clicking copy and edit on the right. Edit it, and then potentially, after you make it public, people will appreciate the work you've done to augment that work. And that's what happened here. I copied a notebook from Mr. Ortikov and made a lot of edits to it, including adding cross validation. And in particular, what I did, I used the time series split library um, from sklearn to is it function? Probably a time series split function in sklearn to to cross validate the time series such that different points in the time series were selected for different for various hyperparameters, and then I looked at what minimized the error across those splits, and that helped me to choose the hyperparameters that I used for the XGBoost model. This conversation today will not talk much about machine learning, so if some of that did not make sense, please allow that to go. I just hope to highlight here that by copying others' work and learning from that work and then adding to it, you can get, as you see, many views. People will copy your own. People actually, participants in the competition copied my notebook 78 times. That purple arrow is covering that. And I did receive enough support to get a silver medal, as you see with the purple arrow. Another thing that you can do as you are engaging Kaggle is by staying engaged and editing your notebook over time, you will stay hot in the ranking. So what you see on the far right is that there were 111 versions of this notebook. A new version is created every time you save it, and that helped me to attract attention to the notebook. Not that that was my goal, but apparently there were folks following my work and showing support. So, also, what individuals are going to monitor, I forgot about my animations here. People will monitor your score. So there is a public leaderboard associated with a public score. You get a score in Kaggle, but based on the data that they have not, how do I say, that against which you are not scored until the end of the competition. So you will not actually know your final ranking until the very end when you can no longer submit, at least in the competitions that I have experienced. So everyone can see your public score, and if that is a good number based on the leaderboard, that attracts attention. I observed here that what I'm showing you here is just that I don't know why I did that actually. 4 months ago is when I last updated this notebook, and then like I said, there were 111 versions of this notebook that helped to attract attention to it, and just speaking to how much obsession I showed with this work. At the bottom right, this Kaggle also has been my chief. Um, until recently at work, my chief opportunity to use ChatGPT and other LLM based aids. So lately, I've been using Copilot, as you see at the bottom right. I'm going to move a window here, which is, I believe it is ChatGPT based by default. I'm sure Kevin can tell me if I'm wrong, but I have been very happy with Copilot, which you can acquire use of by going to Bing.com and clicking Copilot at the top. You may, uh-oh, now it's not progressing. One second, please. Yeah, so if you look at the top right here, you may have wondered why in that little snapshot of the Copilot logo and language, there's a reference to here is your Python code with English comments. So I have just recently engaged a new competition where the objective is to predict who will not make their home mortgage payments. And it's home credit risk model stability. I'm not going to be engaging the stability aspect in this presentation. I'm just getting started. It is interesting, though, that one of the assessments they are using to grade everyone is how well your model can do over time instead of just at a particular time point. Excuse me. I mentioned the hotness rating. So at the around the middle of your screen here, I think you can see my cursor. My recent work on a notebook has caused me to rise to third actually among those that are hot, and that attracts attention. It is kind of silly, but it's fun. It also I find motivating. On the right are screenshots from that notebook, and that also helps explain why this English comments phrase appears. So what I've done is I've copied a gentleman's notebook, and it is in another language. I'm not going to guess which one, Southeast Asian, I would imagine as a region. But what you can see is that as I was working through this notebook and its cells, I decided to first copy those cells into Copilot and ask for the English comments. What that is doing as someone who has programmed in R for years primarily is help me to understand the Python and of course the notebook. So I find this a more engaging way to do work versus just reading books or looking at articles. Engaged learning, I should say. So this competition, as I said, who we're looking to see which records or what are the predictors of defaulting on these loans. There are 465 predictors that they provide you, 27 gigabytes of data, and at the bottom I show a distribution of that target variable. So most of the time, people are not defaulting as you would expect. So we're this is a needle in the haystack kind of predictive challenge, and with so many variables, it's hard to know where to start. Pardon me, hard to know where to start. So for some reason, I cannot progress again. Yeah. So one way to approach it, and you can look at my notebook. I can provide these slides. Is to look at a scatter plot to get a sense of not a scatter plot. Gosh, I'm sorry, guys. It's been a long day. Uh, a correlogram, a correlation heat map. And what you're looking at here is of those 465 predictors, I looked at the top 20, I think, one, two, three, four, yeah, top 20 or so predictors in terms of the absolute Pearson correlation value. It turns out that all of those are positive correlations. So as I'm thinking about the predictors and there is a file with the definitions for each predictor, this is a way to get focused on certain predictors. So let's focus on that top one there, PCT, blah blah blah, on the right in bold. That column, the among the two, it's hard to tell because of rounding. Top correlated predictors with the target being 1 if the person defaulted. That predictor is a percentage of installments that were paid 4 or more days past their due date. So for an interval that I'm not sure of, they're going to give you a percentage of those that were late by different number of days. 4 days, as you can see by the correlation, appears to be about as predictive as just being 1 day late. And so that would be something that one would want to analyze better. I highlight at the top that the Python is looking at the absolute value of the correlations. That is what we're um, ranking and then getting the top 10 or so predictors in this correlogram. The bottom shows that this is a positive correlation. So, as you would expect, as the percentage of installments that are late goes up, a person is more likely to default on their next payment. So, that's a positive correlation with the target being 0 or 1. Target goes up, the likelihood of missing a past installment goes up. And now I'm not brown nosing, but I do want to go ahead and say that Kevin Fiesel was an inspiration for this presentation. I do have his book here to my right, and look forward to continuing to study it. And I will discuss why I haven't been able to use the book's techniques to the degree that I would like yet. So I do hope to have another opportunity to do that. I'll talk more about that in the future, but it is it's an encouraging book. It's an interesting book. I love his psychological take on anomaly detection, and he talks about that in this video at the bottom right as well. So I encourage checking it out. His GitHub page also was an inspiration for me. This scikit post hocs package was, wow, that was bigger than I thought. Was a package that I noticed was not in the Kaggle notebook, and exploring its usage taught me something new about Kaggle. Quite a bit on the slide. So that scikit post hocs package was generating an error in the Kaggle notebook, as you can see on the left. So I wasn't sure what to do. And this is the first time in a Kaggle notebook I have operated a switch for the internet. This competition does not allow you to submit and get scored on predictions if you activate that internet switch and therefore enable internet access. However, for the purpose of exploration, exploratory data analysis, as for the purpose of exploration, we can turn the internet on and then, as you see at the bottom, install a package. So this creates a lot of opportunities to use the free to use resources through Kaggle and explore various packages and according techniques. Unfortunately, I had some trouble with using the outlier detection techniques that I quickly found in the book, and some others I found. So this is an example of a pretty simple and fast technique one can use. You may be familiar with a z-score, which essentially relates an observation to the mean, um, standardized on the standard deviation, which is a measure of variability in short. A z-score in this case that's greater than 7 would be extremely unlikely if the data are normally distributed. Now I'm going to pause here and note that I think throughout the rest of this presentation, I decided not to engage much, and maybe not at all, with normality testing. So please understand that some of the tests that are used here are dependent on the predictor being normally distributed, having a bell shape. I think that I'll be engaging that in a future presentation. Nevertheless, for the purpose of exploration and a fun Kaggle competition, if we choose, we can jump in and then, to the degree that we would like, engage in more careful work. And I find that to be just interesting anyway. Because, for example, maybe a test that is dependent on on a normal distribution in order to perform as it um, was developed to perform can still be useful to us. In this case, we're looking for observations in this uh, 1.5 million record data set that have, for a subset of predictors, values that are exceeding 7 z-score, a z-score greater than 7, which is a very unlikely observation in a normal distribution, enables us to trim all that data down to just 3 records. It turns out that only 3 records for the top 3 predictors yielded an outlier based on that definition. So again, this is just a way to take a lot of data and reduce it down. There are other ways to do this, of course, dimensionality reduction in the world of variables. But I also hope you see that this is an easily used technique. The code on screen is all that was needed. 3 records come out. At the bottom, you see 3 observations in this 1.5 million record data set that have striking values for the top 3 predictors. In this case, we're looking at the percentage of installments that were late by more than 4 days. So we'll look at those observations a little bit. A lot on the screen here. So what I'm doing is I'm subsetting. Now, if you see the number 20 at the top left, I'm subsetting a data set with only 20 columns Why the subsetting of columns, by the way? It was because the work was taking too long to complete and likely would have failed if I had waited long enough. And I did see failures with some techniques that I used. So just for the purpose of exploration, I reduced the data set to those predictors most correlated with the target in terms of the Pearson correlation absolute value. So once I used this outlier detection technique on the top three correlated variables, I then looked at the top 20 correlated variables and looked to see what those records were like with respect to the 20 columns. And what jumped out at me was, of course, as we've already evaluated with our test, being late by more than 4 days on a payment was that percentage was very much an outlier for these three records. But for the first and third record, the Z score was also quite high, greater than 6 for 6 days or late. But then, intriguingly, this second record that you see, observation 447059, actually had a low Z score. So something in terms of absolute value, something much closer to the mean. So what that means is that a person, this individual was quite late, 4 days or more relative to the population, but not surprisingly late, 6 days or more. So it might be that when we're doing our work, we could explore dropping that 4 day variable, depending on how frequently this occurs, and just using the 6 day late variable because I'm thinking that, and you may have experienced this, a person may not be penalized for being late unless it is greater than, say, 5 days. So that is an opportunity to reduce the amount of columns that one is worrying about, at least for initial exploration. It's also interesting that none of these records, these three records, despite being profound outliers with respect to being 4 days late on payments, were nearly as strong of outliers with um, which is about all of the other variables that were strongly correlated with target. So, and that is what you see on the right. These are smaller values with respect to the z-scores. So it's just a way to help engage all this data in a more concise way and to maintain momentum. So I'm hopefully showing as I proceed through this presentation is how I explore problems, and maybe my first approach does not yield what I want, but by finding something that does work, I then see a next step, and that makes it easier to stay engaged with the work and explore. So at this time, I have experienced quite a bit of failure. So I'll talk a little bit about this. Kevin's book talks about the local correlation integral. I have invited him to interrupt at any time if he likes. I'll just say it's a density-based multivariate approach. It exhausted, I misspelled that term there, it was a typo. I exhausted Kaggle notebook memory with that approach. KNN, K nearest neighbors also exhausted the Kaggle resources. And my amateur attempts to use Kevin's Python to extract the techniques that he has used in his book have failed so far. I'm going to show that a little bit. And I'm excited to finally get that working in the next presentation that I hope to do. Let's jump back for a little bit. As I said at the outset, I want to talk about using both R and Python. I have primarily been an R programmer. There is a package in R called Reticulate that enables you to use Python within R. And it also, in a broader sense, enables interoperability. So you can go back and forth between R and Python, which I find a pleasure to do. I find, I'm always looking for ways to make learning more interesting and to keep me engaged. And to be able to bounce back and forth between Python and R is quite motivating. So in RStudio, to talk about this, and I hope you will reach out if you explore after doing this. In RStudio, you install the Reticulate package. And then what I discovered is upon attempting to activate the REPL, the read, evaluate, print loop that enables interactive execution of Python from within RStudio, I could not get this question box to go away. Clicking yes repeatedly uh, presented the box, and if I hit no or cancel, then I experience this error at the bottom. To get by that, you have to install underscore miniconda. And finally, I was able to use the basic reticulate functions that are expected to operate in any environment in which one has successfully installed reticulate. Pi_config, a function in the reticulate package, gives you information concerning what your Python environment is like. What I do not show here is that you can also change your Python environment. There is a reticulate function to enable that if you find that's needed in order to use the packages that you like. So once everything was installed, I had the REPL involved, and then I found myself unable to use the simple pandas package, which anyone that has been using Python is probably familiar with the pandas package, and I was surprised that it was not installed by default. So I created a vector with a number of packages that I wanted to use. There's that scikit_posthox again. Here I'm showing, this is just sort of a nifty way of showing how the reticulate package allows you to mix R and Python. I'm using the R function sapply on that packages vector with the function pi_module_available, which is in the reticulate package, to see what packages among those I have installed. So the reticulate package automatically gave me the math package, which you see via the true, and NumPy, which is true, but for the rest of these, where there was a false, there was a need to install them. I could then pass packages into sapply, this time applying the pi_install function to install these Python packages from within RStudio. I will tell you that this takes longer, much longer, than installing, oh, I hope you can't hear that noise, installing R packages. So just to prepare you for some patience. Let's talk about another Kaggle competition. I've spoken about this one in the past, including to the North Ohio, oh no, gosh, forgive me, guys, North Ohio database group. Uh, One of the other board members, it might have been Tracy or Mala, connected me with that group, and I was able to talk about this competition along with presenting the TriPass. This is probably the competition that I was most passionate about and contributed to the most. GoDaddy, what are they exactly? Web hosting company, sponsored this competition to predict micro business densities in United States counties. Micro business density refers to the density of businesses 10 individuals or less relative to the adult population. Provided with that competition was this training data set, census_starter.csv, that included a few years data from the American Community Survey operated by the census, which they do every year. And you could get predictors like the percentage of individuals with broadband and median household income. So you might predict that where there is a high percentage of counties, I'm sorry, where there is a high percentage of residents with broadband internet, we might be seeing counties that are going to have higher densities of individuals that are starting businesses, for example. Same for income, perhaps. All of that could be explored in this competition. Excuse me. I often speak about the Tidy Census R package. If you have not explored this package, I hope you will. And as a Python programmer, I do not know if there was a similar. I just realized I think Tidy Census is now available on Python, so that makes its R requirement moot. But for a long time, Tidy Census has been exclusively available through R and greatly facilitated acquiring and searching through census data. There are so many variables that the US Census provides about populations. I have this quote on the screen. I think there's value in understanding that the American Community Survey is produced every year and it has 5-year estimates that it is statistically producing. So it is considered to be quite valuable, and as this quote says, is among it is the Census Bureau's most cited economic and demographic estimate provider. you can go online and find the Census Reporter to explore the American Community Survey data. And then what you see on the screen is our uses of the Tidy Census package to explore that data. What the Tidy Census package will allow you to do is, say you wanted to explore counties like with this GoDaddy micro business density competition. Even though the census data are collected at the block group, Tidy Census will, which is the smallest census unit, Tidy Census will aggregate that data to county and provide that to you in a nice, concise way that you can then use. In this case, you could see the total population as well as the number of unemployed in a county with a very concise R code on your screen. In that competition, it was interesting to look at various counties and the variability across time in that micro business density. In the competition, the challenge was to predict some months out of micro business density. So when the competition closed, it was some months before we had our final ranking because we were ranked based on months that had not yet occurred at the time of the competition submission period ending. Rio Grande County, as you can see, showed a pretty nice even slope, and then in the last few months, it trailed off. And predicting that would be a challenge, of course. This competition was interesting because every county was ranked the same regardless of population. So micro business density is already standardized to the population. And so what that means is that a very large, well-populated county would contribute to one score just as much as a very small county. I think Rio Grande County, Colorado, is a quite uh, sparsely populated county, so predicting its values across time is more difficult. If you have not worked with R, we may have a combination of R and Python programmers on the call, and I saw quite a few folks are new to TriPass, and we welcome you. So, just wanted to show a little R code. ggplot2 is I'm much more familiar with ggplot2 and R package to create data visualizations than say matplotlib in Python. So what I'm going to say may not be accurate anymore, but as far as I know, ggplot2 has been a real selling point for R and much easier to use and more attractive in its data visualizations than what has been available in Python. Please notice that I said has been available. Please mark that back to whatever time would make that language inoffensive. I do look forward to learning more about data visualization capabilities in Python now. Nevertheless, what Hadley Wickham and team offered in this ggplot package through the grammar of graphics makes the code quite easy to understand. What do we want our x-axis to be? X-lab. What our y-axis? Y-lab and a title. We also get the colored syntax in the color argument in RStudio. This is where I am actually, Wake County, North Carolina. That's technically not true. I'm very near Wake County at the moment, but I live in Wake County. And just to show the surprising variability across time, inexplicably, as far as I could tell, you have this drop in micro business density. Of course, please be attentive to the y axis. We aren't looking at a big change, but still, given the axis, the range on the y-axis, that drop in October 2022 would be something that one might explore more deeply to see if one can predict such a change in the micro business density. This also highlights the humility that I find valuable in Kaggle competitions. There can be so many surprising variations in the data, and it's I think an exercise in persistence to keep attempting to do better, even when there are some things that are, as I said, potentially inexplicable based on the data that one has available. I find that those surprises fun. So I'm going to call this quasi time series anomaly detection. Kevin actually has an entire chapter dedicated to time series anomaly, golly, time series anomaly detection. The book is Finding Ghosts in Your Data again. So what we're going to do is take from that micro business density competition the data set loaded into R, and we're going to group by county. That's the CFIPS here, the FIPS code for the county, and create lag variables. So that's per county. We're going back in time 1 month, which was the time interval for the data, and acquiring the prior 1, 2, 3 months micro business density to see how well those predicted the next micro business density in the sequence, the final micro business density that was available. Having created those lagged variables, we can look for outliers to see if there are some interesting observations to make. Kevin engages a Grubbs test in the book, which is a simple univariate test. I think he uses the z-score, I just forgot, but it does take into account both mean and standard deviation. So once the data are loaded in RStudio, there are two ways to do it. Because of the interoperability that one has with the reticulate package, you can convert the data frame in R to a pandas data frame, or as I show on the screen, you can use the pandas package to read the CSV. What I've been doing with the aid of Edge, I'm sorry, Microsoft Copilot, ChatGPT, I often use it in Edge. It sometimes works better. Is taking my R code and asking it to translate it to Python code, and that's what I did here. Some of what you will see in the future slides will include comments that were created by Microsoft Copilot in addition to the code. Sometimes when copying and pasting from Copilot, the indentations will not be exactly right. So that is what I'm showing on the right primarily. Is you learn, especially for those of us that are accustomed to not having to worry about white space in languages like R. These experiences making such corrections help to internalize the techniques needed for writing in Python. So when you're working with the reticulate package, there could be a surprising failure of packages to work. In this case, I wanted to use the outlier utils package. At first, there was a failure using the py_install function. By including method equals pip, the package seemed to install just fine, as you can see on this # line. The communication is that the package was already installed at this time. But then when I attempted to import it, no module named outlier_utils was the error. I could do nothing with that package. This helped me to learn that on anaconda.org, you can look up a package and see where it is installed, excuse me, where it is installed, and also for what platforms the package is available for use. My sense is that the challenge I was having, at least using the reticulate package, was that I could not use this OSX64 package on my Windows machine. So just a little, I wanted to point that out. I did spend a lot of time trying to figure out this error, and hopefully this will save you some time as you are experimenting. In the video that I referenced earlier, Kevin referenced the PYOD Python outlier detection package. So I wanted to use that. I could not get the data type to be correct. I'm not very familiar with arrays of this kind yet. So I just want to highlight that if you encounter this problem, it might be best to try another package. This also is a way to highlight the r_to_pi function here. As I said earlier, along with being able to execute a data loading function in Python, you could load the data, such as with read_csv from the readr package. You could load data into R and then convert that R data frame to a pandas data frame, which is what r_to_pi does, and then work with the Python code. I eventually was able to get this scikit post hocs package to work. I needed pip equals true in order to install it. However, when I say work, I really mean provide output. The values that I experienced when I looked at outliers using the outliers underscore grubs function were not sensible. Um, you can see that these values are not unusual for micro business density. I forgot to point that out. I think I'm looking at micro business density is what I'm looking at in particular. This is a column, not a data frame. I misspoke a little earlier. So these are normal. I mean, they're not special values for micro business density. This is a noteworthy value. You'll notice that when I use the grubs.test function from the outliers package in R, 284 was the micro business density that came out as the outlier. The grubs test gives you only one outlier, which I enjoy as someone that can get overwhelmed by all the data, as I've mentioned more than 3 or 4 times now. I think it's nice to be able to find something that statistically is indicated as an outlier, but it is indeed just one thing, and then one can go from there with explorations. This is a test that is dependent in order to perform as developed on normally distributed data. As I said at the outset, I'm just skipping over that for the purpose of this presentation. This is cool. So this shows you how you can run a series of Python lines from within R. All you have to do is capture those lines with proper indentation as a string. Then it's captured into this object Python underscore code. Py underscore run underscore string enables you to run that code. This is all from within RStudio. I then converted those 3 lags that I mentioned earlier, those 3 prior values of micro business density, subset to where most the farthest back value was not missing. So I'm only looking at later data. Yeah. Then I'm converting that into a pandas data frame so that I can use this function that is created here, LOCI underscore outlier underscore test. I just forgot what LOCI is, but it is in Kevin's book and is a multivariate outlier aid, outlying detection aid.
Oh, it's called a
Unfortunately,
local correlation integral.
thank you so much. Thank you so much. Local correlation integral. As you can see, this failed. This needed to allocate 47 gigs. My computer only has 8. So it's a valuable technique, but even for the smaller data set of this competition versus other competitions that I've done, I was not able to use this test. There is a potential opportunity in Kaggle to use. If you pay, you can get access to. I can't remember. I think it's Google Colab notebooks that perhaps would allow one to run an outlier detection technique like this because of the greater resources. So that is something I would like to explore. Just a reminder, what I was doing was looking to see if I could find a technique that would indicate that this was an interesting outlier, this surprising stabilization of the micro business density. In retrospect, because I'm only looking at the last 3 values, this was not a good test. Except what it does do is reinforce what the test is doing. So I was able to get the elliptic envelope outlier detection technique to work. Uh, just a data visualization on the side in multivariate space. Somehow there is a condensation to two dimensions being performed. I'm not going into this technique. I do want to explore it better. I will say that as a multivariate outlier detection technique, it did work on my local machine. And what did not come out of that outlier detection test were this county or the one I mentioned earlier that's near where I live, Wake County, which makes sense because if we're only looking at the last few values, remember where the 3 prior values are not missing. Excuse me, I'm not saying this right at all. I'm sorry. Because we're looking at where the last 3 values are not missing, we can't be too far left on the curve. So it is actually kind of interesting that along this curve across all the counties, starting after the first few months where we can get data, this stabilization was not interesting. So there may be quite a few counties that are stable in that way. Uh, Regardless, you could then use this technique to find what are actually outliers in multivariate space and go from there. So what we've done today is we've talked about using R and Python interoperably with the aid of the Reticulate R package. You have heard me stutter quite a few times, but I think less than in the past. We've also talked about Kaggle. Like I said, I would love to hear you reach out if you are motivated to try either the Reticulate package or a Kaggle competition. It's very easy to get started. You can copy another individual's notebook, run it, tweak the notebook some, and get on the leaderboard with the score. You can actually get on the leaderboard if you even if you do not change another's notebook and keep your notebook private in case there's any concern about embarrassment. I actually enjoy seeing that others have copied my notebook, as I said earlier, and having one's notebook copied, I do believe aids your ranking in the Kaggle meddling system. We've also talked about using outlier detection to aid the initial engagement of the complicated data that we sometimes find in Kaggle competitions as well as other opportunities. So thank you for your time. Are there any questions?
So there are no questions in chat right now, but everybody, if you do have questions for Rick, get them in there. One question that I'll ask is, so you've worked with Reticulate a bit, and did you ever notice any sort of performance differences between running the Python code natively versus running it through R and Reticulate?
That's a great question. I have not been using so I use Visual Studio at work. So I've not been using Visual Studio Code. So I have not used Visual Studio Code on my computer proximal to the time of running Python from the with the aid of the Reticulate package in R. So I'm actually not sure. Have you actually experimented with that?
Just a tiny bit. I didn't notice much of a difference, but I also haven't done an enormous amount of work with over Reticulate.
Hmm.
And most of what I did was extremely high intensity compute. Anyhow, it was working with Keras.
Oh, right, right. Yeah, I need a
So
more powerful computer for that kind of usage.
yeah, and that was gonna max out the PC regardless.
This is an opportunity to say that Kevin is, or at least was, a competitor in Kaggle competitions. Are you still doing any Kaggle competitions?
No, I haven't done that in a little bit. It's fun, but takes a lot of time.
Yes, it does. That's true. Definitely.
So looks like not any questions in chat, but we do appreciate you taking the time to walk us through. If there's any way that you'd like people to get a hold of you later, is there a good way for that?
LinkedIn would be the best way. Rick Pack, RickPack. Just please tell me that you heard me present today, and I'll be happy to connect with you. And if I did not say thank you for your attention, I enjoy presenting. And yeah, it's always fun to hear what others have learned and are doing. So if you're interested in presenting, I imagine Kevin would enjoy hearing from you.
Very much so. All right. With that, we are going to wrap things up for this evening and for this month's Triangle Area SQL Server User Group meetings. Remember, next month we are going to have all three meetings: Advanced DBA, main meeting, in person, and Data Science and Business Intelligence. We'll also have a couple episodes of Shop Talk, so stay tuned for those. You can find all of those details at meetup.com/trypass. And until we see each other in a future episode, everyone, take care.